Hi there. For this video, we'll be discussing the final method in solving rational equations, and that is the LCD method. So this one is the most versatile since there are some examples that are hard to solve using the first two methods in this series. So by the name itself, LCD, we're talking about here LCMs. So we'll use this concept in solving for those rational equations. So just as an example, if we have C 3 and 4 and we need to determine its LCM, so this is just a recall video. If you want to know more about LCMs, I'll put a link around in this video. So listing out its multiples, we'll have 3, 6, 9, 12, 15, 18, and so on. For 4, we have 4, 8 there, then 12, 16, 20, and so on. So among these numbers, the common one is 12. And since the numbers before 12 out here, there are no common anymore, we say that 12 is the LCM of 3 and 4. So the same idea applies in this one, but this time we'll be dealing with variables and so on. So let's go on immediately to our first example. Let's have 1 over x plus 1 over x squared equals 2 over x cubed. So in this method, our goal is to eliminate the denominators by multiplying a certain factor or a certain number in both sides of the equation. To determine that one, note that we can write this one as 1 over x plus 1 over x times x equals 2 over x times x times x. So what do we multiply in both sides of the equation to eliminate these denominators? We can multiply x times x times x. Why is this the one that will multiply? Because by multiplying x times x times x, or x cubed, we'll be able to cancel this. We'll also be able to cancel this, and we'll also be able to cancel this. And indeed, the LCM of this variables is actually x cubed. So this will become x times x times x over x plus x times x over x times x equals 2 over x times x times x. Oops. There should be times x in the numerator. And then we cancel. So we cancel this one, this one, this one, and this one. Then this one. And then this one out here. So we'll be obtaining x times x is x squared. The middle term will be x, and this one is equal to 2. So this one now here is a quadratic equation, so we know how to solve this one already. We'll simply move this to the left side to obtain x squared plus x minus 2 equals 0, and by factoring, this one factors to x minus 2, it's x plus 2 times x minus 1 equals 0. So for this equality to hold, either this is 0 or this is 0. X plus 2 equals 0 will give us x equals negative 2, and x minus 1 equals 0 will give us x equals 1. Let's square this one. And is this the final answer? Not yet, since we have not yet checked the domain of this rational equation. So observing the denominators out here, we've got x squared, and x cubed. So when will these denominators be equal to 0? These denominators will be equal to 0 if x is equal to 0. So the domain of this rational equation is all real numbers except 0. So clearly, x equals negative 2 and x equals 1 is part of our domain. So we conclude that the answer for this rational equation is x equals negative 2 and x equals 1. Let's have this one last example. Let's have y plus 1 over y minus 1 equals 3 over y plus 1 plus 6 over y squared minus 1. Now this time, let's try to check first the domain. So we check when will this denominators be equal to 0. So y minus 1 will be equal to 0 if y is equal to 1. Y plus 1 will be equal to 0 if y is equal to negative 1. How about for this one? Y squared minus 1 will be equal to 0 if, note that y squared minus 1 can be written as y plus 1 times y minus 1 by difference of two squares. So we know that this one will be equal to 0 if y is equal to negative 1 or y is equal to 1. So in all cases, considering, so let's remove this first. So considering all the cases, we know that the domain for this rational equation is all real numbers except positive negative 1. Now let's go on to our LCD method. So again, recall that from a while ago, we know that this one is equal to y minus 1 times y plus 1. So what do we need to multiply in both sides of the equation to eliminate the denominator? We can multiply y minus 1 times y plus 1. Since by multiplying this, we'll also cancel this one out and this one out. So we'll do just that. So we'll have here, let's just copy this one. Oops. So again, we'll multiply y minus 1 and y plus 1 in both sides of the equation. So on the left side, we'll be left with, by multiplying y minus 1 times y plus 1, this one out here will cancel out and we'll be left with y plus 1 times y plus 1 or y plus 1 squared. On the right side, for this term, when we multiply y minus 1 times y plus 1, the y plus 1 out here would cancel out. So we'll be left with 3 times y minus 1. And for this one, for the last term, note that when we multiply y minus 1 and y plus 1 to this one, we know that y minus 1 times y plus 1 is equal to this. So the whole denominator will just cancel out. So we'll be left with 6. And now let's simplify this one. By the square of the binomial, the left side will have y squared plus 2y plus 1, and on the right side we'll have, distributing this 3, we'll have 3y minus 3 plus 6, or negative 3 plus 6 is simply plus 3. Now we move this to the left side of the equation to obtain y squared, and then 2y minus 3y will be negative y, and then 1 minus 3 will be negative 2. And again, we have a quadratic equation. So by factoring, this one factors 2, y minus 2, and y plus 1. Indeed, when we multiply this 2, we obtain this. And when we add this 2, we'll obtain this one. Since negative 2 plus 1 is negative 1, and we have negative 1 out here. Now for this equation to hold, either this one is equal to 0 or this one is equal to 0. That will give us y minus 2 equals 0 is y equals 2, and y plus 1 equals 0 will give us y equals negative. But going back to our domain, note that positive negative 1 is not included in our domain. This means that y equals negative 1 is not part of our solution. And so our only answer is y equals 2. And that is the final answer for this exam. To end this, here is an exercise that you can work on. So we have here 3z minus 2 over z plus 1 minus 2z plus 5 over z plus 3, and this one is equal to z minus 6 over z plus 3. So that's it for this video. I hope you enjoyed this one, and feel free to comment down below your answers and solutions to this exercise in this video. So that's it, and that's all for this video.